So, the purpose of this video is to calculate slope or find slope in a bunch of different ways, given a graph, given a table, and then lastly given 2 points. You should know here, that slope is known as the change in x over the change in y. Most of the time it does end up being a fraction. You can calculate it like so. The x and y coordinates of your second point take away the x and y coordinates of your first point. More commonly, when given a graph, you may want to think about it in terms of rise over run. Specifically, that means the vertical change divided by the horizontal change. Let's see an example of that here. In this graph, all these lines start at the origin 0, 0. So calculating slope from here is figuring out these slope triangles. How many units did you go up? How many units did you go over? So from 0 up to the point A, this line, zoom in a bit, we went up 3, and then we went right 1. So for A, that point, the slope would be equal to 3 over 1, otherwise known as 3. Remember, it's the change in y divided by the change in x. The answer here is not 1/3. Let's do another, maybe letter D. This time around, maybe we'll go right 2 up 1. Right 2 up 1. For letter D, we have, let's see, change in y. So we went vertical change, the rise is 1, and we went right 2. Our slope here is 1/2. Investigate more points. Let's try letter H. That seems interesting. 1 point down there. So from the origin, we went down 1, right 1. So this time around, since we went down, we would count that change as -1. We went right 1, so we count that as normal, plain old 1. And for letter H, we have rise -1 divided by 1, overall giving us a slope of -1 for the letter H. Let's try maybe last one, F. For letter F, it went 1, 2, 3 units left, 1 unit down. So for letter F, it has a slope of -1. Remember, vertical change is on top, and 3. So we have a slope of -1/3. You can do a couple more examples here. These colored triangles I've drawn are commonly called slope triangles. We're making use of the rise over run definition of slope, vertical change over horizontal change. Let's see what it looks like when we go to a table. So here we have 2 tables. Same idea of slope will happen. Let's use purple. So we think about, what's my change in x and change in y? Going here, we notice the pattern. Change in y's, they're all +1s. And then what's our change in x's? How do I get from -3 up to 3? +3, +3, +3, +3. So in this case, our change in y's over our change in x's equals 1 over 3. Again, we have a slope of 1/3 here in 2a. Maybe in a darker purple, we can continue that pattern over here. Whoa, copy something wrong? Maybe, maybe not. So on the right side, 2b, notice this pattern changes slightly. Should have been a -1, I think. +1, +1, +1, +1 pattern. Here we have a +2, +2, +2 pattern. So our change in y over change in x is 1 over 2. That's our slope. That's how you find slope given a table. Figure out the change in your x's and your y's. Here, the most common step when we're given 2 points, how do we determine the slope of a line? In this case, we'll make use of this formula. You've seen me do so in class. M is y2 minus y1 over x2 minus x1. You've seen me do this a lot in class, and I encourage you to do so you keep your points organized, is to label the x and y coordinates of each point with the little ones underneath. So, based on my labeling, this is 2 minus a negative 2 all over 6 minus 1. In other words, taking away a negative is like adding a positive. We have something that looks like this. For 3a, we have a slope of 4/5. Specifically, 4/5 is the slope between 1 and negative 2 and 6 and 2. Next example, more of the same stuff. Calculating slope. Here's my change in y. Do my labeling. y2. So we have negative 2, take away 4, divided by x2, 1 minus negative 3. Negative 6 over, write this step out, it's like adding a positive. So we have plus 3, negative 6 over 4, negative 3 over 2 is my slope. Okay, take it again, another example, and then we'll skip forward. M equals y2 minus y1 all over x2 and x1. Another set of labeling, x2, y2. We have 2 minus 5, 6 minus 4, negative 3, and we have 4 at the bottom. So our slope here is negative 3/4. I'll skip over 3D as an example. You should get 1/5 as your answer there. M equals 1/5. You can show your work and practice this on your own. Now for these last type of problems, you are to determine what the value of r is so that these 2 points have the given slope. This one involves a little bit more algebra. So in these problems, the setup remains the same. You figure out what your slope is using this version of the slope formula. Label your points just like from before. Okay, and now put in those numbers. Take away 2 divided by negative 1, take away 3. And now, let's simplify this a little bit more. Over negative 1 minus 3, we know what that is, that's negative 4. Okay, equals, make use of this part, all of this equals 2. So then, our problem becomes solving this equation, r minus 2 divided by 4 equals 2. When we say solve, we want to figure out what the value of r is. Let's first multiply both sides by negative 4, so that this part makes 1. We're left with r minus 2 equals negative 8. From here, we can add 2 to both sides. Undo that subtraction, this makes 0. R, therefore, equals negative 6. You could go back in, like right here, right? You can check your work. Did I solve for the right r value? Negative 6, take away 2, divided by negative 1 minus 3. We have negative 8. Sorry, negative 8. divided by -4. Doesn't that in fact equal 2? Yes, it does. A little bit more algebra heavy, still uses this definition, this formula for slope. Should get real comfortable with calculating that. Let's see, let's do this one, and then we'll call it here. If you want to check over your work, let's figure out what the answer is here. 3b, your r value is -2. If you want more practice, do 3b. I'm going to skip over 4d. R here should be -5. And as the last example, I'll do 4c. Setup looks like writing out your slope formula. x2 minus x1. Labeling the x-coordinate of my first point, the x-coordinate of my second point, along with the y-coordinates of my second point. Plugging those numbers in, substituting them in other words, doing a little bit of simplification, equals -1/3. Now it becomes a matter of solving a proportion. From here, we can do some cross multiplying, something like this. Okay. So then in light blue we have 3 times 3. I guess green. Now I have this purple color. That's where we have -1 times 1 minus r. So on this side we have 9. All that equals -1. I'm distributing this, okay? So -1 times 1 gives me -1. -1 times -r gives me plus r. Now we have to solve this equation. Okay. Add 1 to both sides. This makes 0. We have 10 equals r. Not much. We're done. See you next time.